In a game of roulette, a player can place an $11 bet on the number 8 and have a 1 out of 38 probability of winning. If the metal ball lands on 8, the player gets to keep the $11 paid to play the game, and the player is awarded an additional $385. Otherwise, the player is awarded nothing and the casino takes the player's $11. Find the expected value, E of x, to the player for the one play of the game. If x is the gain to a player in a game of chance, then E of x is usually negative. This value gives the average amount per game the player can expect to lose. In this problem, we're finding the expected value. So let's write out that formula. Now, x is going to be the gain. So we have two scenarios. We have either the possibility of the player winning or the player losing. We have the gain, and we also have the probability of that gain. Now, if a player wins, they win or they gain $385. If they lose $11. So to mark that as a gain, we would mark it as a negative number, negative 11. The probability of winning in our example is 1 out of 38. Therefore, the probability of losing is the complement, or 37 out of 38. Okay, and just as a side note, that's the same thing as 1 minus 1 out of 38. Now, let's find the expected value by multiplying our gain by each individual probability. So we have 385 times the probability of that occurring plus negative 11 times the probability of that occurring. Now, to make this easier, I'm going to enter this entire expression into my calculator at one time. Here I have an online calculator that I've found. So we're going to enter in our expression. We have 385 times, now to enter in the fraction, I'm going to use a set of parentheses, and I'm going to use division as the fraction bar. Enclose that in parentheses, then we're going to add. For the negative 11, I'm going to also enclose that in parentheses. And then I'm going to multiply that negative 11 times 37 out of 38. Now notice here that I have two beginnings of the parentheses, so I'm going to enclose the fraction in that parentheses, and I'm also going to enclose that last part in a parentheses. Enter. Now you can see that my expression is all equal to approximately negative 0.5789. And since we're dealing with money, we're going to go ahead and round it to the nearest hundredth, or negative 0.58, and we'll include that dollar sign. So the expected value is negative 0.58. In other words, when a player plays this game, they can expect to lose 58 cents on each play.